Okay. So, back on terms of diagonals, let's look at these two, right? We know one must be, can't go there because of the x, one must be the head of one of those diagonals, right? I don't think this gives us much info though. Well, this must be either 2 or 8, but because that can't be 2 because the box is an 8. That's an 8. That is a 2. The remaining ones in this box are 4, 5, 7, and 9. This cannot be 5 or 9 or 4 because 4 by column and 5 and 9 by box. So that would have to be a 7. This rules out a 7 from being here, which makes this 3, as well as one of either 2 or 4. It can't be 2 there because of column. This puts 3 in here, there, and that must be 3, 6, which we can solve. Now 7 has to go there, which puts 7 there. We've got 4, 5, and 9 left. We know 4 is in one of those two in terms of row. Oh, that cannot be a 7, so that's an 8. So that must be a 9, that must be a 7. So that's a 1, 2 pair, isn't it? That must be 7 and 9, of which that would have to be either 7 or 9. But it can't be 9 because of that. So that one must be a 7. So that is a 9. That is a 7. And this cannot be 1, 4, 7. And it cannot be 3, 6, 9. So that would have to be 2, 5, 8. That is a 2. There is 5, 8 pair, which we can solve. That's 1, that's 2. 5 goes there. That is a 1 pair. That cannot be 2, so they are 3, 4. So that cannot be a 4. That's either 5 or 9. That cannot be a 5, that's either 4 or 9. That cannot be a 4. So that must be a 4. That must be a 9. No, a 9, it would be a 1. That's a 9. That's a 1. Right? So now we have something breaking. Yeah, okay. So what do we want to do here? I don't entirely know what it means by no negative constraint for the dots. The only thing I can maybe think of is that those aren't specifically 159, in which case, what could they be? The links in a triangle, so I feel like they have to be some combo of 155. The question would be, like, what? Okay. Okay. Obviously this can't be 2, because it breaks this from multi-constraint. We know that for certain. We know that this fermenter is forced. We know that is a definite. We know that can't be a 2, and this has to be a palindrome, so that can't be 2. Therefore, definite both 8s, that is a 2. We know this cannot be 1, 2, 2, 4, or 4, 8. That is for definite a 3, 6. If a definite puts 3 down here, we know 7 must be is maybe assuming that. I feel like there can't be 4, 5, or 7 regardless anyway. Yeah, we know, for example, say that's a 5, 6, 7. 7 can't be on the black dot. The only evens we've got left are 6 and 8. Or the only two that we could go on are 6 and 8. If it was an 8, this can't fill up. The only thing I can think of, right, they must increase. So they cannot stay the same, so you can't make an argument of both of those being 9 technically makes the thermometer work. That has to be a 6, and that has to be a 5. That has to be a 3. That could be a 2, but we would know that. This could be 8, 9, I guess. That's an option. Maybe this is 8. Maybe what we're doing wrong is that's an 8, 9. That is a 7. And that one of those is a 1. What does that do? I mean, no, that's definitely 3, that's definitely 6. Place a 6 on one of those. I think this is probably what is wrong, or I didn't get. Okay, so let's go back to what we were doing. I guess that means if we're assuming that's different, then those are probably still forced as 7s. That still makes. Oh, but that would break because that can't be a 7. So what could be going on here? Yeah, that alone is wrong, which means that probably. Okay, so we were right then with what we were actually thinking. Those are forced as 7s for definite, which makes that a guaranteed 7. That has to be an 8, that has to be a 9, that has to be a 7. That is a. We don't. So what were we doing wrong then? So that means, yeah, 9 can't go in here because we can't have an 8. So they are 1, 2. So those do contain a 9. They do contain a 7. That is forced as a 4. Okay. We would have a 7 in one of those. So this has to be 2, 5, 8. Which puts a 8 on one of those. That is forced as a 2 or a 5. That would be some sort of combo of 2, 5. And if 4 is in one of those, the 4 can't go there, so that has to be some combo of 1, 4, 7. Let's say 7 there. Makes that a 1. Makes those 5 and 9. Oh yeah, there's a 3 there, so that's 1. That's 2. That can't be a 5. That can't be a 4. No, it can't be 6, 7, 8, 9 because it's already been used there. And we've already messed something up. So what could it be? For example, let's see, I'm correct with just the assumption that that has to be 4. Yes, okay. Don't. But we know that, I think, the assumption that I think has to be a 7, I think is also correct. It's not. So the thing is, right, this cannot be 3, 6, 9, because if it was, 3 and 6 can't go here. They would both have to go here, which wouldn't work. If it was 2, 5, 8, like that could be a 2. The problem we would have is that 4 cannot go in there in the column or there in the row, which forces a 4 in one of those. It'll make that a 4, which makes that a 4, which breaks the box. So that would have to be 1, 4, 7. I was saying, okay, maybe what's going wrong here is I'm misunderstanding how teal lines work. That might be what's going on. Okay, I'll leave it there. So what I think this might be doing is I think there is a 4 on here, but I'm pretty sure what it's saying is that it isn't 147 as the set, but I think it's saying that this 1 in this set, 1 in this set, and 1 in this set. Yeah, okay. I get how this works now. Got it. Shouldn't run into any problems now. Okay, so let's go back to this then. We know whatever, like, I guess we don't know which, like, you say is the thing. We know 7 has to be on one of those two. That's a 7 or 9. But it can't be 9, that must be 7. Okay, so with the knowledge that I now know how these work, that's I think what broke it last time. Well, like the first time. Rather. That's a 6, we can place that down. That isn't a 6. So we know there isn't a 6 on here. And we know 3 can't be on here either, so that has to be a 9. So that is a 9. I'm going to try and refrain from checking. I'm just going to see if it is simply a misunderstanding thing. Although I probably should split here. Yeah, I think I'll split here.